Hello everyone, I am Dr. Virikul Sreshth and today I am going to discuss a very demanding topic of 11th standard chemistry, and that is Lee-Chatlier principle. Very important because you will be getting questions in the examination definitely from this topic, and very easy also because once you understand it you will never forget this thing. So let us start with Lee-Chatlier principle. I should tell you that Lee-Chatlier principle tells us actually about the factors which are responsible for the shifting of equilibrium. That reaction which is in equilibrium want to be in equilibrium because this is the comfortable state for the reaction. So what are the factors which can shift this equilibrium? Means the factors which can make the equilibrium shift in such a way so that more product will be formed, or they can shift the reaction in such a way so that the more reactant can come back, yani the reaction can be shifted in such a way so that it will make the more product, or the reaction can be shifted so that it will make product into reactant, it will convert the product into reactant. And what are these factors? Basically we will discuss about these 5 factors, and the first factor is concentration of reactant and product. Second factor is temperature. Third is pressure. Fourth is catalyst, and fifth one is addition of inert gases. So one by one I am taking all the factors above, like the starting 3 factors. These 3 factors we will understand in the topic, under the topic called Lee-Chatlier principle, because this principle talks only about these 3 factors. These two we will be discussing but in a separate way. So let's start with the Lee-Chatlier principle. It states that if a system is in equilibrium, in equilibrium, is subjected to a change, which type of change? Change of pressure, temperature, or concentration of reactant or product. Concentration of reactant or product. Equilibrium shifts in the direction to undo the change effect. So this is Lee-Chatlier principle. What does it? It states that if a system is in equilibrium, is subjected to a change, means the reaction which is already existing in equilibrium and you are making changes in that. What kind of changes in pressure, temperature, or the concentration of the reactant? So if the system is in equilibrium, is subjected to a change in the pressure, temperature, or concentration of the reactant or product, किसी में भी change करते हैं, तो your equilibrium will have tendency to shift itself in such a way so that it can undo the change effect. Means it want to exist in the same way as it used to be. So if you are increasing pressure, it will start decreasing it. If you are adding more reactant, it will shift them to the product side because it does not want more reactant. If you are adding more product, it will shift to the backward side so that it will not have that much amount of product. तो जैसा है वैसा condition में it will try to exist. Hence, it will try to undo the changes you made in it. We will understand one by one the different type of effects. So first of all, we will see how the concentration of the reactant in product affect equilibrium. ठीक है, एक एक करके देखते हैं. तो concentration of the reactant and product I am taking. So let's take a reaction to understand it in a better way. So this is A and B reacting to form C plus D. Now in this particular reaction which is in equilibrium, I have to show it like this because if the reaction is in equilibrium, we have to show this double side arrow. That is, it can proceed in the forward as well as in the backward direction. So in this particular case, if I am increasing the amount, the concentration of A and B, and equilibrium is also existing here. It is in the comfortable state. I am disturbing the equilibrium by increasing the concentration of A and B. So what this equilibrium will do, it will start shifting its reaction in such a way so that A and B कम हो जाए, because I made the changes by increasing, तो वो AB को कम करेगा. How it is going to decrease the AB? By converting this AB into CD. So your reaction will go into the forward direction. Same way, if I am increasing C and D means I am increasing the product. तो क्या होगा? Product are increased means the changes will be done in such a way so the product will be lesser. And how it will happen? Because the reaction will, in that case, the reaction will move in the backward direction. Q, so that C and D will be converted back into A and B. So we can easily see here, if we want more product, we have to increase the reactant so that the equilibrium will be shifted to the right hand side, to the forward reaction. And if never we want this thing कि we want कि आपका reactant products कम हो जाए. Always in the commercial processes we want कि reactant should be increased so that products should increase. ठीक है. Another way to increase the product may be what? We can decrease the concentration of C and D. So if we are decreasing the concentration, equilibrium will try to increase the concentration of C and D. And कैसे होगा? A and B will start converting into C and D. So if you don't want to increase the concentration of A and B to make the more product, you can decrease the concentration. तो या तो आप इसे बढ़ा दीजिए so that shift हो जाए reaction इधर, या फिर इसे कम कर दीजिए तब भी reaction will be shifted to the forward direction. I hope it is clear that we have to increase the reactant so that we can get the more product, or we have to decrease the product so that जैसे ही ये कम होंगे ये टूटना शुरू कर देगा, ये इनको बनाना शुरू कर देगा, because it want to exist at the equilibrium state. No kind of changes it want. जो आप करेंगे उसका उल्टा process will be started so that अगर आप इंक्रीज करेंगे प्रेशर तो प्रेशर कम करने की कोशिश करेगा, दैट अमाउंट द प्रेशर ऑफ दैट सब्सटेंस जो आपने इंक्रीज किया है. आई होप इट इज क्लियर. वी कैन शो दिस चेंज effect of concentration of reactant and product by using a reaction. I am taking this reaction and the reaction is Fe plus 2 in the aqueous state, यानी Fe plus ions which are yellow in color, they react with the SCN ions in aqueous state to form a product which is a complex compound FeSCN plus 2. Color of this ion, which is also in aqueous state, this is reddish brown. This is colorless. Just because we are talking about the reaction which is in the equilibrium, so ये reaction भी when that color is not changing, we can say that equilibrium has been reached. Now neither the products are being formed nor the reactant are being formed, or I can say the reactant and the product are being formed at the same rate so that the color of the system is not changing, because the same amount of reactant and product are available at that particular state. ठीक है. अब सब just as I have told you कि the color is between the yellow and reddish brown. Now the color is stabilized and we can see the equilibrium has been reached. अब हमने क्या किया? We have increased iron, this ion Fe plus 2 ion. तो if I am increasing this Fe plus 2 ion, किसको increase किया? इसको increase किया. So what will happen? On increasing Fe plus ion, we observed that the color is getting darkened. यानी that color which was yellowish kind of started turning into darker color. So color become dark. Color darkens. What does it mean? It means the more products are being formed because dark color is of FeSCN plus 2. So this is dark color appears there. Next is, if I had started increasing this compound, this ion, so on increasing this, what we have observed that the dark color started moving towards the yellowish side. It becomes yellow. So what is happening there? On increasing the concentration of the reactant, color becomes darker because the more products are being formed which are reddish brown in color. On the other hand side, if I started increasing the amount of the product, what we observed? We observed that the color is getting lighter because of the formation of more reactant. तो अगर आपने इसे बढ़ाया तो ये इंक्रीज हो गया, यानी कि रिएक्शन इज गोइंग टू द फॉरवर्ड डायरेक्शन सो दैट ये कम हो जाए. आपने इसे बनाया तो रिएक्शन बैक में जाना शुरू हो गई और ये बनने शुरू हो गए. Why Fe+2? Because so that ये consume हो जाए. And how it is going to be consumed? To give the reaction in the backward direction. So I hope it is clear to you that the concentration of the reactant and product can affect the equilibrium in such a way so that concentration of the reactant and product जो है वो जैसा था वैसा रहे. अगर आपने कंसंट्रेशन बढ़ाया है तो कंसंट्रेशन को वो कम करेगा इक्विलिब्रियम, और अगर आपने कंसंट्रेशन कम किया है तो उस पर्टिकुलर प्रोडक्ट या रिएक्टेंट की कंसंट्रेशन विल बी इंक्रीज्ड सो दैट आपको प्रोडक्ट ज़्यादा मिले या रिएक्टेंट ज़्यादा मिले. आई एम गेटिंग दिस. नेक्स्ट इज टेम्परेचर. नेक्स्ट इज टेम्परेचर इफेक्ट. So effect of temperature is very important, but before understanding this temperature, the effect of this temperature, we have to understand that there are two types of reaction. First type of reactions are exothermic in nature, and second type of reactions are endothermic in nature. Now all of you must be knowing in exothermic reaction, heat or energy is released. Okay. And in endothermic reaction, energy or heat is absorbed. We don't bother about whether the heat is released or the heat is absorbed. The main thing is if you are increasing the temperature, system अपना temperature अपने को इस तरीके से शिफ्ट करेगा so that the temperature will start decreasing. For an example, if there is a reaction A plus B equals to C, this is endothermic. Okay, so if this change A to B, A plus B equals to C is an exothermic in nature, so obviously this opposite reaction will be, this is endothermic, so this will become exothermic in nature. Okay, so these two reactions are opposite in nature. If this energy is consumed this way, energy will be definitely released in opposite direction. So I am starting from, if you are increasing the temperature and your reaction is endothermic. Okay, आपने क्या किया? You have increased the temperature and the reaction is endothermic. So means the reaction will go in such a way so that temperature is being absorbed. तो किस डायरेक्शन में का टेम्परेचर इज बीइंग अब्सॉर्ब्ड? यू कैन सी देयर इफ द रिएक्शन विल मूव from this side to this side, it is endothermic, so reaction will be absorbed, that temperature will be absorbed only when the reaction is moving this way. तो reaction कैसे चलेगी? In the forward direction, because you have increased the temperature and temperature has to be maintained by the absorption of energy. That will happen. Now the next thing is, if the temperature is decreased, मान लीजिए आपने क्या किया, you have changed the temperature. मान लीजिए suppose the reaction is taking place at the 700 Kelvin easily, and what you have done is you have decreased the temperature. आपने टेम्परेचर कम किया, अब उसको क्या करना है? ऑपोजिट करना है. आपने कम किया है तो उसे टेम्परेचर बढ़ाना पड़ेगा. अब टेम्परेचर किस तरफ बढ़ेगा? यू टेल मी, टेम्परेचर किस तरफ बढ़ेगा? टेम्परेचर बढ़ेगा जहाँ एक्सोथर्मिक रिएक्शन है, isn't it? Because the heat has to be released. आपने कम किया है ना, तो उसको बदला लेना है. So what will happen? The temperature will increase only in case of exothermic reaction. So what it will do is, it will go in this way, means in the backward direction to form the product, so that exothermic reaction हो और आपने जो टेम्परेचर कम किया है वो टेम्परेचर फिर से बढ़ जाए. Doesn't matter. Reaction does not want to make product. Reaction does not want to convert back into the reactant. It just want to be in equilibrium in the comfortable state, so that whenever you make any changes, it will just undo the change. It will just do just convert itself. It will just shift itself in such a way so that वो आपके किए हुए चेंज को अंडू कर दे. आप टेम्परेचर बढ़ा रहे हैं तो इट विल स्टार्ट डिक्रीजिंग द टेम्परेचर. तो जो भी आप कर रहे हैं दैट विल अंडू दैट चेंज. Now let's take a real example of this for this particular concept. That is, if I am taking a reaction called N2 plus H2 equals NH3. ठीक है, for this particular reaction delta H is negative and this is 92.4 kilojoules per mole. Negative, are you understanding? Negative plus means endothermic, negative means exothermic. So your reaction is exothermic. Okay, so your reaction is exothermic in nature, means if you want to make the product, okay, if you want to make the product, what kind of changes you have to take place, you have to go for, so that आपके products ज़्यादा बन जाए. तो for the exothermic reaction, suppose you have increased the temperature. Okay, so if you have increased the temperature, reaction is exothermic this way, so obviously the reaction will be endothermic in the another way, and you have increased the temperature, तो reaction क्या करेगी, it will start moving in such a way so that the energy will be consumed. और कौन सा process है, which side it has to move so that the energy will be consumed? Reverse direction. So it is going to come back if you are increasing the temperature. So if you want the reaction to take place in this way, you have to decrease temperature. So decrease in temperature will favor a reaction which is exothermic in nature. आप इस बात को ऐसे भी समझ सकते हैं, suppose reaction आपकी exothermic है, it is comfortably happening at the मतलब without heat because it is already releasing the heat. So why you are providing the heat to that reaction? Just use the common sense that you cannot make the reaction comfortable. Which kind of reaction? जो कि already exothermic है, it is releasing its heat already. There heat is in excess, energy is in excess in that reaction. That is why it is releasing heat, है ना? And you are providing more heat and you are expecting that reaction will be comfortable. Not possible. If you don't have that particular amount of heat, that reaction want heat, then you are giving heat, then it is comfortable and it will take the heat and will go on fasting. Same way, suppose I am dissolving sugar into the water, and what you might have observed, that sugar will be dissolved in the water on increasing temperature. Means if you increase more and more temperature, the sugar will be dissolved in more and more amount. Why? Because dissolution of sugar in the water is an endothermic process. और जैसे ही आपने गर्म किया पानी, again the more sugar will be dissolved so that the heat will be consumed. Because it is endothermic process, more and more dissolution will be possible. Same way we can take another example, that is nitrogen and oxygen. Nitrogen and oxygen gas combine to form nitrogen oxide, and for this particular reaction delta H की value is plus 180.7 kilojoules per mole. Okay, so can you understand here, this is positive and positive means endothermic. Okay, so because it is endothermic, इसे heat चाहिए, it needs heat, तो आप कराइए provide. This is endothermic. Okay, this side process is endothermic. You have increased the temperature, the reaction will proceed in such a way so that reaction में जो आपने temperature बढ़ाया है वो consume हो जाए. And what direction is consuming the temperature? That is the temperature will be consumed in the forward way. So for the endothermic reaction, if you are increasing the temperature, it will forward in the direction to make the product. So for the endothermic reaction, make a note. एंडोथर्मिक रिएक्शन के लिए Kc हायर होगा if temperature is high. If you want to shift your reaction to the product side, increase the temperature so that Kc will be increased. Kc increase होने का मतलब है आपका प्रोडक्ट इंक्रीज कर रहे हैं. अगर आपका रिएक्शन इज एक्सोथर्मिक तो Kc will be increased only when you decrease the temperature. क्योंकि टेम्परेचर बढ़ाएंगे तो वो कंफर्टेबल नहीं करेगा रिएक्शन, बिकॉज ऑलरेडी इट इज रिलीजिंग द temperature. ठीक है. So now I am taking the effect of pressure on the equilibrium condition. The effect of pressure will lead to the forward reaction, or effect of pressure will lead to the backward reaction. The very first thing which we have to understand here is the pressure is directly proportional to the number of moles. Okay, just understand this concept that if there are no more number of particles in any reaction mixture, the more number of particles will create the more pressure in the mixture. Okay, so this concept we have to keep in mind, and then we'll proceed accordingly. So I am taking a reaction to make it clear to you how it will affect the change. So the reaction is that N2O4 is dissociating to give you NO2. NO2. So balance the reaction. N2O4 is dissociating to give you NO2. This reaction is going on. Now, how the pressure will affect this particular reaction? You have to understand here, more the number of moles, more will be the pressure. Less the number of moles, less is the pressure. So here we have more pressure, and here we have less pressure. ओके, अब अगर इधर कम है इधर ज़्यादा है, यू हैव इंक्रीज्ड द प्रेशर. आपने क्या किया? यू हैव इंक्रीज द प्रेशर सो दैट यू वांट टू सी व्हाट विल बी द इफेक्ट. यू इंक्रीज द प्रेशर, तो रिएक्शन विल स्टार्ट मूविंग इन सच अ वे कि कुछ भी करके प्रेशर कम हो जाए. एंड हाउ इट विल हैपन? कहाँ जाएगी रिएक्शन? टू द बैक डायरेक्शन, बिकॉज here we are having low pressure, so it will start moving to the direction having less number of moles, क्योंकि less number of moles means less pressure, and reaction will shift. In that case the reaction will shift to the backward direction. Now just suppose I am decreasing the pressure. I am decreasing the pressure means the product will start moving that way where the pressure is more. So at the lower pressure, the products will be formed in the more amount, because the reaction will move in the forward direction. I hope it is clear. Let's take one more example to understand it. I am taking this another reaction. Common example, N2 plus H2 equals to 2NH3. First of all, count the number of moles. 2 moles, 3 plus 1, 3 plus 1, 4 moles. So you must be understanding here, the pressure is less here this side and pressure is more here this side. So if I increase the pressure, in that case, more pressure will make the changes in the equilibrium. अब मैंने change किया temperature pressure increase करके. What this reaction will start doing it for itself to remain at the equilibrium? It will shift itself so that more pressure से कम pressure होना शुरू हो जाए. And how is it possible? It is possible only when the more product will be formed. तो कुल मिला के you just remember this thing, the equilibrium on increasing the pressure. On increasing the pressure, I am writing it here. Increasing pressure, equilibrium will shift in the direction having less number of moles. Doesn't matter कि वो reactant है या product है, whatever it is, it will start going to that direction जहाँ पे कम number of moles होंगे. In this particular reaction, if I am increasing the pressure, if more pressure is there, the equilibrium will shift in this direction so that less number of moles will be formed. क्योंकि pressure will decrease in that way only. That number of moles less means the pressure is less because you have increased the pressure. I hope it is clear to you. Suppose there is a reaction now. I am taking H2 plus I2, which gives you 2HI. This type of reaction where the number of moles are same means 2 moles this side, 2 moles this side. If 2 moles are on the right hand side, 2 moles are on the left hand side, what happen if I increase the pressure in that kind of reaction? No change, because reaction is not having changes in its moles. The pressure is same type, like pressure is same in both the direction, in both the side. So what will happen if you increase the pressure or this type of reaction, there will be no effect of the pressure on this reaction. You can increase the pressure, you can decrease the pressure, it doesn't matter. The temperature, catalyst and rest of the factors will work for these reactions, but not pressure. Okay. Second important thing which I forgot to tell you here, that is pressure related reactions. Like pressure is the major factor in those reactions which are in the gaseous state. So gaseous statement is more significant because in the liquids the pressure is not that important factor. Is it clear? Now we'll talk about the catalyst, how the catalyst affect the casing, how the catalyst affect the reaction in the forward and in the backward direction, and how it starts shifting the reaction. So the important thing is catalyst increases the reaction. We know that catalyst either increase the reaction or decrease the reaction. So catalyst will increase the reaction in the forward direction as well as it increase the reaction in the backward direction, because the catalyst affect both the rates, that is in the forward rate and the backward rate in the same way. ओके, टू द सेम एक्सटेंट. तो अगर आपने राइट साइड का भी, यानी यू हैव इंक्रीज द स्पीड ऑफ द राइट रिएक्शन, द स्पीड ऑफ द लेफ्ट रिएक्शन, ultimately what will happen, the equilibrium will be reached faster but it will not be shifted. So make sure that you are not taking this catalyst as a factor which can change the Kc. So no change in the case of catalyst. Why? Because it changes both the direction, both the rates, forward rate and the backward rate of the reaction. Hence there is no change in the reaction Kc if you are if you are adding the catalyst to the reaction. Now let's take the another effect, and that is the fifth effect called effect of addition of inert gas. So what we are doing this time? We are going to add inert gas in the system which is already present at the equilibrium. So we will understand the effect in under the two headings, and this is at constant volume. First of all, we will understand what will happen when we will add the inert gas in the container which is having a fixed volume. We are not allowing the mixture to increase the volume. So here this is your container which is having a fixed volume. Here is a substance A filled. Here is the substance B filled. Suppose this is gas. Okay. Now they are dispersed very evenly. It is a homogeneous solution which is going to react. Now on the other hand side, what is going on? Third substance, that is inert gas, in the fixed volume, inert gas is also added, but the volume is not allowed. So the partial pressure of each component, can you understand? The partial pressure of each component is ultimately not increasing or decreasing, क्योंकि in the unit volume amount of substance is fixed here. Although inert gas is participating there, but partial pressure, यानी that pressure of that particular component is not changing at all. तो क्या होगा कि constant volume पर on adding inert gas there will be no change in the pressure. Hence there will be no change in the equilibrium state. So the Kc will not shift in case if you are adding the inert gas at the constant volume. But what if we are if we are adding it at the constant pressure? आपने pressure constant कर दिया. The second condition is at constant pressure. So if the constant pressure is there, means it is allowed to increase the volume. So pressure is constant. You have added inert gas to it, you have introduced inert gas to it, due to which the equilibrium shifts in, due to which the volume increases. So pressure is same, the volume increase. Now just imagine I have taken a volume here. This is A, spread it here. This is B, spread it here throughout the container. Now you have started adding the inert gas into it with the constant pressure. प्रेशर आप अगर बढ़ाएंगे तो ये इसकी वॉल्यूम को लिमिटेड रहेगी. इफ यू आर नॉट इंक्रीज चेंजिंग मेकिंग चेंज इन द प्रेशर तो वॉल्यूम विल इंक्रीज बिकॉज ऑफ द एडिशन ऑफ मोर inert gas. तो क्या होगा, this inert gas will be introduced, means the pressure inside will increase, which will lead to the increase in the volume. तो this is going to shift here like this. तो ये जो है volume is increased. Now what will happen? Now these will occupy the space available there. So the particles will be shifted from one side to another. Can you see there? So the per unit volume, the amount, the concentration or the pressure of the particles will decrease. So क्या होगा, the pressure ultimately will decrease because the volume is increased. Because we know this thing, PV equals to nRT से हमें पता है that pressure is inversely proportional to volume. So what you have done is you have increased the volume. और जैसे ही आपने वॉल्यूम बढ़ाया क्या हुआ, प्रेशर कम हो गया. जैसे ही प्रेशर कम हुआ तो चेंजेस pressure is decrease. So basically यहाँ पे आप बस इतना समझिए that change क्या किया आपने, change is decrease pressure. So always remember, when you add inert gas at the constant pressure, you will decrease the pressure because you will increase the volume. More is the volume, less is the pressure. Up when you decrease the pressure, reaction will move in such a way so that pressure बढ़ जाए. So if a reaction is A plus B equals C, count the number of moles, 1 mole and 2 moles. You have decreased the pressure. The reaction will move in the reverse direction क्योंकि आपने reaction में pressure कम किया है ना, तो ये pressure बढ़ाएगी. pressure कैसे? Number of moles are directly proportional to the pressure. तो more number of moles की तरफ shift होगी. So do remember, in case of addition of inert gas, equilibrium will shift in such a way so that in the direction where more number of moles are present. More number of moles. In the direction, आप इसको नोट कर लीजिए, in the direction, reaction will shift in the direction having number of moles. Shift in the direction having more number of moles. तो reaction will shift this way. अगर ये reaction उल्टी होती, just assume I am taking this time A plus B equals C plus D 2D. Okay. Now what is happening? इस टाइप की रिएक्शन में where 2 plus 1 equals to 3 and 1 plus 1 2. There are moles, 3 moles on the right hand side. You have increased, you have added inert gas to it, due to which volume is increased, due to which pressure कम हो गया. प्रेशर कम हुआ तो इसको अब प्रेशर बढ़ाना है to undo the change. जैसे ही ये प्रेशर बढ़ाएगा किधर जाने की कोशिश करेगा so that ये प्रेशर बढ़ जाए. प्रेशर will be increased only when the moles will be more. So it will shift the way, shift the reaction in the forward direction so that the pressure will increase. I hope it is clear to you that in these kind of examples you can see there that pressure is playing a very important role. That is constant pressure पर तो it will shift in such a way so that number of moles जहाँ ज़्यादा होंगी वहाँ पे ये reaction shift हो जाएगी. I hope it is clear. Now let us talk about why we are talking about this effect of pressure, temperature and many other factors. Why we are talking about? Because we want the products in the commercial processes. So whenever we are manufacturing anything, we are manufacturing, that is why we want the more product. So when we want the manufacturing units, we want to make the condition comfortable for the reaction so that it can proceed in the forward direction only. So we will apply this knowledge in the various manufacturing units, and I am taking one by one so some of the example of these kind of manufacturing unit. For an example, first of all I am taking the preparation of nitrogen oxide. The first example is preparation of nitrogen oxide. This is formed by the Binklint-Ide process. Binklint-Ide process. During this process, What happens during this process? Nitrogen oxide is formed by the nitrogen and oxygen gas. So what I am taking here is nitrogen reacting with the oxygen to form nitrogen oxide. Balance the reaction because it is important. It is playing a very important role to assess what will be the effect of the temperature, pressure and rest of the factors. Okay, so I am starting it with N2 plus O2, which is making nitrogen oxide. First of all, I am going to mention the temperature, what type of heat changes takes place for this particular reaction. This reaction is having enthalpy 180.7 kilojoules per mole. Can you see there it is positive? If it is positive, endothermic process. Endothermic. Now just tell me the comfortable conditions for this particular reaction to take place. So what preparation you will do for the manufacturing unit so that you will get the maximum product. Now we can see here positive means endothermic process. If it is endothermic, if you increase the temperature, if you are increasing the temperature, reaction will go in the same in the direction where the energy is being consumed. So what is the direction? Forward direction, क्योंकि it is endothermic. So if you are increasing the temperature, reaction will proceed in the forward direction. So comfortable state will be more temperature. First state, to increase the temperature, reaction will move to the forward direction. Second, let us see, is there any effect of the pressure? अगर आप pressure में changes करते हैं तो क्या इस पे कोई effect आएगा? No, because there are 2 units on the right hand side and 2 moles on the left hand side. So if both the side are having same number of moles, if you increase the pressure or decrease the pressure, that will lead no change in the equilibrium. Next is what will happen if you increase the reactant? Obviously, more is the number of reactant, more will be the shifting towards the forward side. So more the reactant, increase in concentration of N2 or O2 will increase the products. ठीक है? So if you want the more product, pressure रहना चाहिए, जो भी हो doesn't matter, temperature should be more and increase in concentration, more and more, N2 and O2 you will add, more and more product you will be getting. Same way I am taking one more example, and that is sulfur dioxide. When it is reacting with sulfur, when it is reacting with the oxygen, it can make SO3, sulfur trioxide. It is contact process which is used in the preparation of H2SO4. Contact process. It is a part of contact process, which is a very common process, very important process for the manufacture of H2SO4 sulfuric acid. So the second example is SO2 and O2 react to form sulfur trioxide. Now just imagine if I am increasing the temperature, but उसके लिए मुझे क्या चाहिए? What is the delta H for the reaction? The delta H for this particular reaction is 193 kilojoules per mole. All of you can see there. ये भी पॉजिटिव है. पॉजिटिव मीन्स ये भी एंडोथर्मिक है. इफ इट इज एंडोथर्मिक, increase the temperature, it will comfort your reaction. More is the temperature, reaction will move to the forward direction. क्योंकि आपने टेम्परेचर बढ़ाया है तो ये टेम्परेचर कम करेगी, और क्योंकि एंडोथर्मिक है टेम्परेचर कब कम होगा? When it will consume the energy. ठीक. Same way, if I am increasing the pressure, so 2 moles on the right hand side, balance the reaction. I have not balanced it now. So this is what? 2 moles on the right hand side and 3 moles. Can you see there? 2 mole and 1 mole. 3 moles on the left hand side. If you increase the pressure, the reaction will shift in the direction where the moles are less. तो अगर आपकी reaction में आप pressure बढ़ाते हैं तो it will shift to the right hand side. Means pressure increase will comfort this reaction and you will get the more product or increasing pressure. So more pressure. Now let's talk about what will happen if you increase the SO2 and NO2. या तो SO2 बढ़ाइए या O2 बढ़ाइए, you will increase the product, because reactant के केस में तो always if you increase the amount of reactant, pressure of the reactant, if you increase the amount of the reactant, concentration of the reactant, it will lead to the formation of product in more amount. So this is how the condition affects the formation of various product. That is the factor decides whether the reaction will proceed to the forward direction or it will proceed to the backward direction. So I hope this video will be helpful for you to understand Lee-Chatlier principle, and we can now determine how what kind of factors are responsible for making the reaction comfortable so that it will give us maximum products, because ultimately we want product खूप सारे हों. So I hope this video will help you to make this thing clear to you that how the factors, various factors affect the state of equilibrium. If you like this video, please hit the like button, share it and subscribe my channel. Thank you very much.